Hello, everyone. Thanks for sticking around till the end. I'm going to present an update on Common Experiment 1 and our kind of the problem that we're seeking to address with this study is improving the synchrony of nitrogen fertilizer inputs and crop uptake. So we know in our dominant corn and cotton production systems, they're typically managed with high rates of nitrogen, and only a portion of the nitrogen fertilizer inputs are used by the crop. And generally around 30 to 50% can be lost to the environment, which has negative consequences. And so kind of to advance this goal of precision sustainable agriculture, we want to address how cover crop system, how nitrogen fertilizer can be managed best in cover crop based systems. So our hypothesis, basically, by retaining or fixing nitrogen in the case of a legume, the cover crop can provide some nitrogen to the cash crop and thus reduce what we call the agronomic optimum nitrogen rate, or the rate that's going to maximize yield, or the economic optimum nitrogen rate, the rate that would maximize profits. And we hypothesized that the ability of those cover crops to substitute for those fertilizer inputs will depend on climate management, soil properties, and cover crop characteristics like quantity and quality. Next slide, please. So with Common Experiment 1, it's a field study that's located at 15 different locations throughout the US that are shown on this map, and we've divided those into 3 regions: the north transition in purple there, and the south in red. And those are differentiated just based on the legume cover crop that's used, as well as the cash crop. And I'll talk about those more specifically in a moment. But the factors in this field study are cover crop treatment. So we have a cereal rye, a legume, either crimson clover or hairy vetch, a rye legume mix, and no cover. And those are replicated 4 times at each location. And within each of those cover crop main plots, we have 6 subplots that represent a range of different nitrogen rates, spanning from insufficient all the way to excessive. And within that gradient of nitrogen rates, we'll measure the corn or cotton yield and figure out what was the nitrogen rate that reached that plateau of yield, so the minimum nitrogen required to maximize yield. Next slide, please. So kind of the conceptual model, the yield optimizing nitrogen rate has proven challenging to predict for a given field or in a given year. And that's because it's directly impacted by 3 things: soil nitrogen supply, crop nitrogen demand, and nitrogen losses. And those are in turn impacted by things that can be hard to predict, like the weather, variable soil properties, and management practices. Next slide, please. And then with the introduction of a cover crop, either a grass or a legume cover crop, we have potential impacts on the soil nitrogen supply, on the yield potential, nitrogen losses. Typically, the cover crop is designed to reduce nitrogen losses. And so the goal really is to understand how the cover crop, both the presence of a cover crop and then the species or the mixture, is impacting that agronomic optimum nitrogen rate, and how is it doing that. Next slide, please. And so our timeline here is it's a 3-year field study. We began planning last fall, and this fall we've got the cover crops planted, and we're now kind of in the phase of developing our protocols for the cash crop, whether that's corn or cotton. So we're we are now in progress on the first year of this study. Next slide, please. I wanted to introduce some of the new team members since our last full meeting. So Lucas Caniceres is visiting scholar right now. He's wrapping up his PhD, but he'll be transitioning into a postdoc position with me at the University of Kentucky. And he is leading the coordinated data collection, so managing all the spreadsheets and analyzing data and writing for the CE1 team. And he comes with a background in cover crops and nitrogen dynamics in corn. And that's what he's been working on for his PhD. And he's also got a master's in hydraulics and sanitary engineering. And I think he's on the call today. I don't know if he wants to say hello.
I'm here, but yeah, I think Hanna already introduced me, so thank you.
Thank you. He helped put together this presentation as well, so thank you. All right. Next slide, please. We also have Resham. He's already presented today, and he's an important member of CE1. He's a postdoc with Stephen and has been focusing on the cover crop decomposition and advising the team on the litter bag methodology. But he just finished his PhD at University of Maryland, and he's also got his master's degree from North Dakota State. And next slide. So I'll let Andrea introduce Tawana if she can be unmuted.
Sure. I think I had control of that. So thanks, Hannah. I just wanted to briefly introduce Tawana Almeida to the team. She is working on her PhD here at the University of Nebraska, and she has a master's in soil science and worked last summer actually as a visiting scholar with Justin McMecken, who is a part of, he's an entomologist at UNL and part of Common Experiment 2. It's when I met her when she was here last year and convinced her to participate in this project. So her dissertation is going to include elements of both Common Experiment 1, 2, and on-farm research. And she's really been doing an outstanding job working with us from afar. And so she's been stuck in limbo in Brazil with visa issues and COVID and whatnot. And I only mention that because I just thought it'd be a good reminder for all of us that we are in the middle of a very unusual situation, even though we're plugging away with work, that it can be a challenging time. This is one unfortunate piece of it, but we're glad for the technology that we can, stay in touch, and she's been able to, help us with protocols and designing our experiments and all of that. And I also wanted to recognize that I have some support from a postdoc who's now helping me with various projects. His name's Salvador Ramirez. He wasn't able to be on this morning. He recently finished his PhD in our department. He worked with Dr. Ray Dreiber, who's a soil microbiologist. That's his area of expertise, but helping me with some data collection, project management, organizing, and all of that. So if Tawana wants to say anything, I'll let her, but appreciate the opportunity to introduce her.
Thank you. We're glad to have her. And then we have Yogi, and I don't know, is Mike on the call? There's a lot of people here to scroll through. Mike, if you're on, would you like to introduce Yogi?
Yeah, I'd probably prefer that Yogi introduce himself.
Okay.
Thank you so much. My name is Yogendra Upadhyay, and I'm from Nepal. And I completed my undergrad in agriculture from Tribhuvan University. And I came to US for my master's, and I completed my master's in environmental studies from Kentucky State University. And right now I'm a PhD student with Dr. Mulvini, and I'm working on cover crops and cover crop nitrogen credit to the cash crop. And also we are planning to see the impact of cover crops on wheat population and also on soil moisture and soil temperature. Thank you so much. And I'm very happy to be part of this team. Yeah, thank you.
Thank you. We're glad you're here. And then I also wanted to mention that Lisa Foltz will be bringing on a new PhD student as well. If Lisa would like to say anything about Andreas.
Yeah, sure. So Andreas actually comes from Guatemala. He's part of the Zamorano school, excuse me, in Honduras. He actually came to work for me last semester on some of our cover crop projects, doing an internship, and fingers crossed, everything is T's are crossed, I's are dotted. He will be able to start with us in January on this project.
Cool, thanks. Next slide. And I also wanted to mention some of our staff who've been doing a great job implementing this study at various locations. And I'm probably missing some, but I wanted to at least highlight the ones that have been pretty active on the calls. And if I'm missing anybody who would like to be introduced, please let me know. I think, all right. And then we have kind of switching gears. So our 3 regions are the North, Transition, and South, and they are just differentiated based on the legume cover crop and the cash crop. So the northern locations are growing hairy vetch as their legume, and followed by corn as their main cash crop. And then the transition region is growing crimson clover as the legume and corn as the cash crop. And the southern region is crimson clover followed by cotton. And you can see, especially for the north and transition regions, we integrated these cover crop systems following either small grain or forage crop, whether that's silage corn or forage soybean. A few locations followed corn, but our goal was really to get the cover crops planted rather early in the northern and transition locations to get the most out of the legume. Next slide, please. So I just kind of take you through photos of some of our recent activities. We soil sampled each of our fields with the goal of characterizing the soil properties as one of our kind of inputs into the data analysis. So we took deep soil cores all the way to 90 centimeters for determining soil texture and organic matter, kind of exchange capacity, may look through extractable nutrients, pH, kind of a full profile characterization of each field. Next slide. And then around the time, so we soil sampled around the time of cover crop planting to get a good indication of how much soil in organic N was available when those cover crops were planted. And this is a photo from Florida where they were planting the cover crop treatments. Next slide. This is some of the cereal rye growing in Wisconsin plots. Next slide. And we've also taken stand counts shortly after emergence. So this is Andrea, I think this is Andrea in Nebraska, taking stand counts of the cereal rye. It looks like in addition to the stand counts, we took biomass at the time of the first hard frost or early December, whichever happened first. Next slide, please. We were pretty satisfied in Kentucky with the mixture. It was planted in first couple weeks of September, and we got very nice ground cover and nice establishment, I think. Next slide, please. And the clover in Florida was looking really nice. So thank you for sharing those photos. All right, next slide. I also wanted to mention some of the outreach work that's come out of our CE1. And so I would like to turn it over to Heather to talk a little bit about what they've been doing to integrate this into their extension.
Great, thanks, Hannah. Hi, everyone. It's great to see you all virtually. And I thought this was a great opportunity. I know we're going to be talking more about extension tomorrow. But again, we heard a little bit about how extension is integrating within the social science team. And I also thought it was important to show how extension will be and is being integrated into our various common experiments. So this spring, I think everybody around the country was basically in lockdown and also throughout the summer. And we were really trying to figure out ways to continue connecting with the farmers and stakeholders that we work with. So we did a bunch of different activities and started a virtual Field Day Friday series that we started at the end of July and went through September, and each week highlighting experiments or topics. And so week 4, we filmed Lindsay. You can see her up in the photo when we were actually planting CE1 and talking about the experiment. So made a video and then hosted this virtual field day where we showed the video, talked about the experiments as well as many other experiments too. And you can see, you know, we didn't have a ton of viewers. It was the middle of the summer or fall, but we still had about 40 participants. And now those have been archived and are posted on our YouTube site, and people are able to view them. And in fact, you can see they are viewing them. And then a few weeks later, we also did another series on cover crops, and again highlighted the common experiments that we were doing in those field days as well. So we'll talk about this more tomorrow when we're talking about extension, but you know, at least on our end, we're starting to highlight the projects, even in its most basic you know, start, which is just planting and just telling people what we're doing. So thanks, Hannah, for the time. Appreciate
Thanks.
it.
All right, next slide. So we don't have a lot of data just yet, but we are starting to collect it, and I thought I'd share the data, some of the data that we do have. And this is our stand counts in plants per meter. And the locations here are presented in order from south to north. We don't have data yet from all locations, but we've got 6 here. And we have in green the legume counts, and in red or in yellow the rye counts. And on the x-axis you can see the legume monoculture, the mixture, and the rye monoculture. And so in general, the stands for the legume and the rye were higher in monoculture than mixture, which was according to our seeding rates. But the thing that I thought was interesting is the higher stand counts of the legume in the southern locations, and then the higher stand counts of the rye in the northern locations. So kind of already starting to see how the northern locations emergence of the legume may not be quite as good, or initial growth, since it's a bit colder. Next slide. And this is just kind of to sum up, our overall goal again is to develop more precise nitrogen fertilizer rates for cover crop based corn and cotton systems regionally and cover crop specific to kind of add on to our overall precision agriculture goals. And final slide now is just some contact information. We do meet each month on the last Wednesday at 11 a.m. And I also wanted to advertise that Dr. Shalimar Armstrong is looking for a postdoc who I think would be in part working on this. And so if you know anybody who might be interested, please contact him. And that's all that I have. Thank you.